Hey, today we're going to be working on long division, but not just any long division. It's long division of polynomials, which is kind of fun once you get used to it. And I know you think I'm nuts, but you'll see it's not so bad. We're going to consider looking at a number. Let's consider like going back to fourth grade when we used to do long division with numbers using this type of a method. All right. Of course, in Algebra 2, when we consider division, we consider the fraction bar. But for today's purposes, I think using the division sign is going to help us. So A says, find the result of this division using the standard long division algorithm. And is there a remainder in this division? So basically, what I'm saying is when it says 1519 divided by 7, that means 7 goes on the outside, and the 1519 goes on the inside. Because we read this, 1,519 is divided by 7. So let's go back to the way we used to do this in fourth grade. We'd say, well, 7 goes into 1, 0, so that's an insignificant digit. So we say 7 goes into 15 twice. And 2 times 7 is 14. Then you have to make sure you subtract them. 15 minus 14 is 1, and then we bring down the next digit, which is a 1. So then we ask ourselves the same question now. 7 goes into 11 how many times? Once, and that's 7. 8, 9, 10, 11. So we have a remainder of 4 here. Bring down the last one, which is a 9. And we have 7 goes into 49 7 times. Now in this case, is there a remainder? The answer is no, because we have 49 and we subtract it, we get 0. So no remainder. So now let's consider looking at B. We're going to evaluate 1,522 using long division, and we're going to write our answers in A plus RB form and in the A plus BC form. So let's look at what that means. So let's go and do our division. Remember, what does this mean? 7 goes into 1522. So we're going to follow the same algorithm. 7 goes into 15 twice, 14. We subtract, and we get 1. Bring down the 2. 7 goes into 12 once, 7. With a remainder of 5. Bring down the 2. Let me just slide this up a little bit. And then 7 goes into 52 7 times, and that's 49. And this time we do have a remainder of 3. So how we write that in this A plus BC form, C is going to be our radicand, which is the 7. All right, so it's going to be 217 plus 3 over 7. Or the other way, that R that we have right here, this is the way you used to literally write it in fourth grade, was 217 with a remainder of 3. So hopefully we're jogging your memory a little bit right now. I know it's hard to think back to fourth grade because since middle school we've been using calculators. But we do have to consider those remainders. And in exercise 2 now, we're going to look at what happens when we start introducing polynomials. And we're going to follow the same algorithm. All right, so what that means is that the x plus 6 divides into the 2x squared plus 15x plus 18. So what I really look at here is the x. So what I mean by that is if I look at this x and this 2x, that's really what I'm looking at. So how many times does x go into 2x squared? Well, I can get a 2 here, and I can get an x. All right? So when I multiply 2x times x, I get 2x squared right? And then what did we do next? We subtracted. But the only thing is we didn't forget this one. Because remember, this is 2x times x, and now it's got to be 2x times 6 as well. So I know I have to get plus 12x here. And when we subtract, we're subtracting this whole thing. So when we subtract this, and we subtract this. So these cancel, and 15 minus 12 is 3x, and then we bring down the positive 18. All right, so now we say our x again here goes into our positive 3x plus 3. And now multiply it. Positive 3 times x is positive 3x. Positive 3 times positive 6 is positive 18. And now we subtract. Subtract, subtract, and we get a remainder of 0. So what does this mean? What does this mean? This means that x plus 6 times 2x plus 3 is equal to 2x squared plus 15x plus 18. When there's no remainder, that's what that means. Okay? So now let's look at what happens when we do have a remainder. And again, these are a little tricky. Write down what you need to before we move on to the next one. So if you look at the next one, you'll see that the only difference here is that instead of 2x squared plus 15x plus 18, we're going to get plus 20. So I'm hoping you're kind of realizing what our remainder is going to be right away. So let's do the same thing now. X plus 6 goes into 2x squared plus 15x plus 20. And think about it like this. What's 2x squared divided by x? And it's 2x. So that's what I'm going to put here. 2x. So I get 2x squared plus 12x. I distribute it out. And now what do I have left? I have to make sure you subtract. And when you subtract, subtract this. These cancel. And I'm left again with 3x plus 20 this time. So now again, I can do 3x divided by x, which is 3. So I add 3 and then multiply it through. I get 3x plus 18. Remember to subtract, minus, minus, and I'm left this time with a positive 2. So in this case, and they want it in the form q of x means the quotient. So 2x plus 3 is my quotient right here. This is what I'm looking at. Plus the remainder, which is 2 over my x plus 6, which is what I divided by. Okay, moving on to exercise 3. So when we divide two polynomials, we always get another polynomial and sometimes a remainder. This is known as writing the rational expression in quotient remainder form. All right, so if it does turn out to be a remainder, we get that remainder plus r over whatever we're dividing by, our denominator, if you remember. So let's take a look at the next one. We have x minus 3 into x squared plus 2x minus 5. So the first thing I'm going to ask myself is, what is x squared? How about we do it over here? What is x squared divided by x? And the answer, of course, is x. So now when I multiply, now I'm multiplying this x minus 3 by the x that we have here. So x times x is x squared minus 3x. Now I'm going to subtract. So minus, plus, these cancel, and I get 5x minus 5. And now I get 5x divided by x, which is positive 5, of course. So now multiply this by this, and I get 5x minus 15. Remember now to subtract. Minus, this is one of the places people make the most mistakes. So positive 5 plus 15 is a positive 10 as my remainder. So if I write this in this form right here, I'm going to get my quotient, which is x plus 5, plus 10 over what I divided by, which is x minus 3. So there's my final answer. Going on to B, 2x squared minus 23x plus 17 divided by x minus 10. So the first thing I'm going to say is, what's 2x squared divided by my x? And I get 2x. So that goes here. So now I multiply it through. So 2x times x is 2x squared. 2x times negative 10 is negative 20x. Now we're going to subtract. Minus, plus, these cancel, and I get 3x plus 17. And now I do 3x divided by my x, and I get 3 plus 3. Multiply it out. You get 3x minus 30. Remember to subtract. Minus, plus, and now these cancel, and I'm left with okay, so my mistake, this should have been a negative 3x plus 17, so I should have, instead of being a positive, should be a negative, so it would have been negative here, and then it should have been a positive here, so when we subtracted, this becomes a negative 13. And that's my remainder. So to put this into the correct format would be my quotient, which is 2x, minus 3, I almost made the same mistake. 2x minus 3 with a remainder of negative 13 over what I divided by. Okay, so exercise 4. Write each of the following in the form a plus b over x minus r. So why don't you try these on your own? Pause. As Dee Dee says, try. And come back to me and I'll put the solutions on. Okay, so my 9th period class is just walking in, and we will finish this up. Those are the answers. Check your work. And until next time, what do I always say?
Make good choices.
That's it.